them are in, we can start. So I'm just going to give a few minutes, let's say a minute or two, for everybody to join, and then I'm going to start with today's introduction on the Luxpower inverter and to go on from there. Okay, 10:02, I'm going to start. So it's 1 minute, and then I'm going to start. Okay, I'm going to start. I believe everybody should be here. So let's get everything started so far today. Thank you for joining me in this introduction and training session on the Luxpower inverters. I'm mainly going to talk about the SMA 5000. It's the most popular machine that everybody sells at this moment of the Luxpower in South Africa. So I'm going to go through some of the account setups and some of the specifications and capabilities of this machine and so forth. And then I would also like everybody that's watching, if there's anybody that has a question, ask the question there in the chat box. I'll regularly check if there's any messages there in the chat, so that we can answer certain questions. Feel free to answer questions. That's why we are here, to broaden our knowledge about this machine, to get the best service that we can give the clients about this machine. So yes, let's get started about anything. Before we get started, as I said about the questions, if there's any questions, please feel free to ask the questions in the chat. I see there's a client that's still joined. Okay, he's in. Okay, so to get started on this Luxpower inverter, first things first on this inverters, we have a online monitoring system that we use for this Luxpower inverters. We have our own monitoring system that you can monitor your inverters online anywhere where you are in the world. You can see your specific inverter on your account. You can see what's happening to the inverter and so forth. I'll show that now on the monitoring page as well to you guys. Then we can do settings online. We can do all of that type of stuff that we can do online. So first thing first, I'm going to go to the online view, and I'm just going to give a brief description of how our online monitoring system works and what you can do. As I understand, there's a few resellers here as well as installers. So I'm going to cover both sides, the installer side and the reseller side, on the monitoring page at this moment. So I'm just quickly going to change screens here for you guys. Okay, I presume everybody can see my screen here of what's going on my screen at this moment here. So on the screen, you'll see this is the home page that you'll land on once you have logged into your Luxpower account. So first things first, if you buy your inverter and you're an installer, buy the inverter from the suppliers have distributors accounts that allows them to create installers accounts. Now, installers accounts are extremely important to get it started with. If you don't have an installers account, you can't create end user accounts for your clients, and you can't monitor your clients' accounts and installations that you have done for them. So first things first, for installers, it's very important to get your account set up and ready. So you must ask your distributor to give you an installers account. They will create the installers account, and I'll show that as well a little bit later, how the distributors can create the installers accounts and how to use it. So for the installers, once you have an account, you will get a customer's code. So this is a very important part of your account. Now, a customer's code is assigned to a installer, meaning that every installer has his own customer's code. So once you have this customer's code, you can create end user accounts. So once you install the unit at the client's house, you take the client's phone, you download Luxpower View. That's our mobile app, which you can use to monitor our systems. Then from the Luxpower View app, you can create an end user's account. Now, as soon as you hit the registers button on the app, it will take you through all the steps. You put in the username and the password and the station name, dongle number for the client. And the last thing that you have to enter is the customer's code. Now, the customer's code is how the server knows who was the installer for this specific inverter. So this gives the installer access to the client's site. So once the client has used the installer's customer's code, then the system will automatically be added to the installer's account. So the installer has access over the end user's account. So he can do the settings, he can monitor it and see what's going on with the system if the customer calls in. So the installer don't have to register anything to get the account under his name for the end user if he installed the product. All that he's going to have to do is he's going to have to use his customer's code while the end user is registering his own account, and that account will automatically be added to the installer from there on. So once you have your account, you log in everything. It's the same for all the accounts. Your distributor's account, your installer's accounts, and your end user's accounts can all log into the page that we see here. And all of them will pretty much see exactly the same as we are seeing here. The only difference between the accounts is the level of access on the settings that the different accounts have. So once you've logged into this page, it's Luxpower login. So you can go to Google, type in Luxpower login, and you will find this specific page. So once you've landed on this page, you can click for quick access on this thing, and you can go through all the sites that you have under your name. So you can go to all the sites there, and you can click on a specific site and its information will come up. So once I've clicked on one specific site, I can go have a look on what is happening at this site. For instance, this site that I am on is a UPS type of site. There's no panels. The client bought the inverter and a battery just to have power during load shedding. He has some mining rigs that must run during load shedding as well. He doesn't want them to go off. So he bought the inverter and the battery just for a battery backup for the mining rigs. So at this moment, we can see what is happening from the grid. He's using 1.5 kilowatts and the batteries are at idle at this moment. And then as well, the consumption of the client's house at this moment. Now, in this box here, it shows some of the information that was happening on the system in the history-wise. If you go have a look here. So you can see the total yield for the day, and the total yield, that's the total amount of power that he has yielded so far from the sun since this inverter was online. I'll go to a site which has panels now, and then we can see how this is working. This is just information about the battery to see how much discharge you have discharged this battery so long, and what is the total discharge for the day. And then this is your feed in energy, so that's the power that you exported to the grid, And if you click on the icon, it will change to the power that you have imported from the grid to show you how many units you have used. And this side is the total consumption. That's grid, panels, and batteries combined at that instance there. So this is how you get your monitoring page. This is what 90% of the end users will use, is only the small graph here. Okay. I see at this moment you're asking about the batteries that's slightly discharging at this moment. Okay, what is happening at this instance on the screen here is my buzz line is slightly active. So at this moment, we are seeing a 5-minute delay of what's happening on the inverter. So if something happens on the inverter, you will see it for the next 5 minutes. Your information will stay the same. So on this side, at this moment, we can see a few different parameters of the batteries. So it will charge up to 100%, but at this moment, the 96% is where the battery has stopped to request charge. This is one of the clients that I was working on this morning, that we are sorting a few things out on the communication between his machines. We are losing communication between his battery and the machine, and we have narrowed it down to the communication cable that is not 100% correct between the batteries and the machine. So that's why it's not fully charging. I'll take it to a system nano as well through a few systems, so that we can see what a few systems is doing at this moment here. Yes. At this moment, you'll see here the small amount of power that is here. I've asked the Lux engineers, they say the small amount of power that is active between the machine and the battery at this moment is how the machine improves its switching time. Is the buzz voltage, or the small amount of power that's on my buzz side between the batteries and the inverter, just helps with switching times at the inverter side when ESCOM is not available at that certain instance. So I've asked them about that, and they said it is completely normal. All inverters has a small amount of power that's between the batteries and the inverter. It needs to be active, the line. And as soon as a line is active, there's always a small amount of power that is going in and out of the batteries to keep that specific line active there. Yes, we will definitely talk about battery compatibility as well. Yes, we will run through that one as well. I'll let Meow Meow send the list as well in the chat, so that you guys can download the list so long of the different batteries that is compatible at the moment with the Luxpower. She will share that, as well as the training manual. We will share in the chat with you guys, so you can download it and have the list on hand to explain which batteries is compatible on which protocols at this moment. Here's a slight more in-depth of history-wise of your machine, that you can just see at which time what is happening with your machine. So you can see your discharges and what your battery was doing, and your import and all of that of the machine. So you can go through the days. Is there solar and all of that? You can have a nice graph that you can see what the solar have done. So there's just some information of what was happening on the machine, and just slightly more to the bottom side, it's just a summary of what is happening on the machine on which day. So all your information is combined there: the solar production, your battery, what happened with your battery, and your export and your consumption. So all of that is just a summed up value of what happened that day. Okay, so from here on, for installers wise, installers will always go to the configuration tab once you want to see certain systems. So once you are on configuration, you can go to this, you can go to the stations that you have created. So all this, your stations that you have created, or the end users that you have created, stations will show here. So all the test stations and everything that you create will be at this moment. So if you select a station at this moment, you will go to the information. So let's just quickly go to a completely off-grid station that's been running for a while now. So once you click on a station, you'll see the serial number of this inverter at there. Then you click on this station this side. Okay. Then all the information will be displayed this side. So at this moment, the guys' stations are offline, so you can't see the stations at this moment. Let's just quickly see if it's on the European cluster. Okay. Let's just quickly go back this side. Now his inverters is offline at that moment. Okay. So once you have selected, let's say like a station at this moment and the machines are online, then on the monitoring page, you will see all your details and so forth. So let's go to, if you are here. So from here on, you have history data that's on the machine. So if you go to your data tab, you will see all the information about the system on which day, which was happening on the specific system. Let's just quickly go back to see when his system was completely online. Okay, so from here on, his system was online. So here we can see the data, the voltage of the MPPTs, as it has two MPPTs. I'll get to that specifications as well. You have some data of what's happening on your batteries at that moment, the voltage, the SOC, charge power, and discharge power there. This is for the grid side. This guy doesn't have any grid on the farm. He's on a complete farm between nowhere. So on this side, you can see what his EPS side has done. So this is his amount of power that he's been using on his system, and this is a parallel system. So for you to know if it's a parallel system is you'll see this box with the 6 inverters in. That means your system is in parallel at that specific moment. As soon as you have a parallel system, it's very important to add all your dongles to the same station. So if we go back to his station, you will see he has added all his inverters to the same station. So here his 2 inverters is under the same station. Once you've added them under the same station, you will see the action on the side for parallel. So you go to the first one, you say parallel index, here will be 0. You just type in 1, save, and then at the second one the same. You have parallel index, you type in 2, save. If there's 3, you will go to the third one, 3, 4, 5, 6, depending on the amount of inverters that you have. And a 3-phase or a single-phase system, it stays exactly the same for the paralleling. So this is only for paralleling the monitoring side of the inverters. This has nothing to do with the physical parallel. This is only for the servers to melt the information of your systems together. So on this one, you will see all the information. So all the information that would have been shown here for your batteries and your panels and all of your consumption, all of that would have been the 2 inverters information combined. So that tells everybody that the information is from both inverters and not only one inverter. So that's what's happening on that one there. From there on, if you are an installer or a distributor's account, you can go to maintain. So once you click on the maintain button, you will see that you have the capabilities to do all the settings on the inverter, the different settings. So you can do all this settings on the account there. Then the most important part of your installers and distributors accounts is the capabilities to update inverters. Once you have an inverter that's in parallel or giving you problems, then you as an installer or the distributors have the access to update the inverter. So for you guys, it's quite easy to do it. All that you are going to have to do is you type in the serial number of the specific inverter that you'd like to update, and then it will appear here. As soon as that inverter appears, you can go to the standard update button next to it, and you only select standard update. Once you selected standard update, you will see the, the, the information of the inverter will be displayed here, and the status. So it will show you it is so many percentage, so it's 10%, 20%, 30% away from completion. And then remember, my SNA units, the one that we are talking about today mainly here, has 3 updates on certain versions. So you have a 24, then it will go to 72 and then 76. So my firmware code will be 24, 72, 76. So there's 3 different boards that needs to be updated in an inverter. So after the first update, the inverter will restart. It will wait a few seconds to go through everything and see everything is fine, connect to the internet and continue with the second update. It will restart, do the same, and then continue with the third update. So it's very important to switch over the inverter to the grid, meaning your whole house must run on Eskom while you're updating the inverter. So you should install a changeover switch that you can decide, or the inverter or Eskom is supplying all the loads in the house, because the inverter will restart 2 to 3 times depending on which update is running on this inverter. And every time it restarts it, your Wi-Fi will go off, your fridges will go on and off, and it's not good for all the appliances in the house. So you just flip the changeover switch so everything stays on in the house while the inverter is updating, and the updating will go much faster and smoother once one is doing this. Okay, I see you mean how long does an update take? Okay. Yes, the updates depend on your internet speed. If you have good quality internet and everything is running perfectly, updates can take 10 to 15 minutes and it could be done. If you struggle with your internet and it's not very strong and your connection is not very good, then it can take up to a while depending on all the factors. So updates usually is 20 minutes max. That updates usually takes sometimes shorter, sometimes slightly longer. There's a lot of factors that influence it. From there on, yes, it is necessary to have your inverters switched over, or the whole house switched over to the grid, so that the inverter does not supply load to anything while it is updating. There was a point where certain inverters, after the first update, it will stop giving out EPS power. There was a very big jump between certain firmwares. So if you have an inverter that was last updated last year or January wise, it will stop giving out EPS power after some of the updates. So it is very important to switch it over. And if there's no grid available, that one can make plan to get the inverters online, so that if the inverters restart and stop giving out EPS power, that you have like a small battery operated router or your phone on a hotspot or something like that, just to keep the inverters from updating. And after all 3 updates are done, the inverter will resume working modes normally and it will give out power to supply to your house. Okay, so on this instance, as soon as you have an inverter that fails an update, you don't have to worry about that too much. You will see at the status, it will tell you that the inverter has failed. Here at the action side, there will be a cancel button. So all that you do is you press cancel and you go back to the inverter serial number, you press standard update, and it will start to update again. But it will take off where it stopped. So it means if your update failed at 70% and you cancel it and you go back to the inverter and you say standard update, it will start to update from 70% onwards again. Except if it failed and tomorrow morning you want to update it again, then you have to download the whole update again. But if it failed now and you press the cancel button and say standard update again, it will automatically start to go on from there. So from there on, that's on the standard update side. So from here on, you will see the update record. Now on the update record side, there This is the information that you will see of the history of certain machines that you have updated. So that means you can see here, for instance, this machine has failed its update, that one has failed its update. So you can go on from there on without any problem. So as soon as you have your updates, you can follow the progress. Let's quickly see if I can get a progress that runs quite nice. I believe this one should be really fine. Okay. So at this instance, you can see that this update was successful on this inverter and this update was successful there. Let's see if I can quickly find one that all three was done correctly so that I can have a nice demonstration here for you guys on this one. It seems that I can't find one quickly. I'm not going to hold you up on this one. Okay, so this is also a machine that was updated. There's two successful, and then the third one would have been earlier. So you can follow to see that there's three successfuls or two, depending on which firmware your machine was on. Now, if we go to the remote update again, this is very important to see. Your firmware code will automatically say, let's say 24, 72, 76. Let's go to a normal SNA one. So this is how an SNA's serial number will look. This one is an SNA 5000 inverters update. So you will see it says 24, 71, 75. That's the second newest firmware that we have. At this moment, the 24 is my MPPT board's software. My MPPT board hasn't had an update for the last 3 or 4 updates that was released. So there's only 2 boards that had to be updated. There was only 2 updates to be done. Here's an example of a machine that's MPPT board hasn't been updated. So it was on an old software that was 12. And then if we go down, it should have been much less than that. Okay, here's one. 12, 15, 12. Now, this is one of my first softwares that you will see on the machine. So at this moment, we can see there's an update successful of this client. There's an update successful of this client. And then if we go slightly higher, there's if it was the same unit, it would also have been successful because you can see 24, 71, 75. So the newest firmware at this moment is 24, 72, 76. That's the newest firmware at this moment that is on this machines. So that's for the update side on the machines, how to update it. Distributors and installers has the access. Are there any questions that one have at this moment before I move on from the monitoring page a little bit to specs and this of this inverter? Yes, it's safe to do update on the machines if they are running in parallel mode. I always try to tell the clients if they are in parallel mode to switch off the output breakers of the inverter so that the 2 inverters is not connected to each other, because it will give a parallel fault as soon as one inverter goes to the new firmware and the other one is slightly behind. So that's usually how it is done. I'll exactly explain you what is the recommendations that we have on a parallel system so that you can see what I mean by switching off the outputs of the inverter on the circuit breaker side. Then while I'm on the update, the last thing on the updates that's very important is the machine have to have ESCOM power or PV power to update this unit. The unit's MPPT board is or activated by ESCOM or activated by PV power. And it have to have that to one of that to update. And it is very important. On the bottom of our machines, we have 2 switches. We have an EPS power switch. That means that switches on the EPS. And we have a physical power switch on this inverters. Now, on this inverter, it's important to have both of the switches on when you do an update. If the EPS switches off, the update will fail. You can't update the machine's last update when the EPS switch is off, or ESCOM is not there, or PV power is not there. One of the 2 must be there for your updates to complete. Yes, it is safe to do an update when it's available. Definitely it's safe. But I always tell clients a lot of the times, if a unit is working perfectly and there's nothing wrong with a unit, I always tell them leave the unit as is, except if they said something new in the updates that you would like to know. Um, so I don't update units that works perfectly. As soon as a unit is working perfectly and there's no problem, the client is extremely happy, I leave a system as is, so that there's no possibility for something small to get in that the client is not happy about. But it is safe to update it. We don't have problems with certain updates. So yeah, it's safe to do updates. You won't ruin your system or anything. The system will automatically decide which update files will be loaded to the machine. So there's no way for you to choose the wrong file or something like that. So it's completely safe for you to do updates from there on. Is there any other question that one has on something that they would like to know before we go on? Okay, so I'm going to go on to the next step of the system. I presume everybody's happy on this page here. And then, as I said, here's the setting tabs where you can adjust all the different types of settings that is available on the SNA 5000. Before you do anything, you have to read the settings. So once you press the read button, all the settings will populate. The system is just offline, so it doesn't help I press the read button, but you will see all the settings will populate. And from there on, you can do all the different type of settings that you can have here. And just press set after you've done certain settings. You will see there's the set buttons. Press the set button and the machine will give you confirmation that the after the setting has been updated. Will give a box here that says the parameter has been set successfully. So you can see if parameters and settings has been done correctly. So for here on, I'm going to go back to my training manual. So we've went through the accounts. That's one thing that I still have to quickly show you how to set up the account. That I will do immediately with you now. Then the data logger connecting to the Wi-Fi. I'm going to share a video at the end of this training session that you can go through that exactly shows you how to get this logger online. One of the best ways that I have found to work. So I will share that video to you at the end. I have tried to show the videos in the training sessions, but with Zoom, the sound is bad or the video is bad. So I'm just going to send a complete video so that everybody can download that video and you have it at your disposal to show clients, to send to clients, as well as this training manual. Okay, remote update we have done as well for all the installers. Now, this is a section that I have a lot of people that have their own feelings about it. And that is the requirements, not requirements, but recommendations. So that we have on the units. Now, at this moment, I'll explain exactly why my breakers is the size that my breakers are. Now, remember, this is not a requirement for your warranty to go through. But if you follow this setup that I'm doing here, you have the biggest chance of claiming your warranty without any problems because all your protection was done in such a matter that the machine was protected. So if you can provide, let's say your inverter broke and I know you followed this steps here that I'm going to give you here, then there's no way that we can argue with you that you have damaged my machine. I'll explain exactly why I'm saying what I am saying at this moment. So firstly, I have a 25 input breaker that I recommend the clients have. You can enter whatever size you would like here. I have a 40 amp bypass current that this machine can handle, but I will never go higher than 5 kilowatts worth of power. That's between 20 and 25 amps that you can reach that power. Reason being is if you are in bypass mode and you're pulling 6 to 7 kilowatts through my machine and ESCOM fails at that moment, your machine will go in a direct overload, EPS overload. So that's why I won't go that high. Now, my output breaker, this is where I have a lot of clients that don't agree with me. That's more than fine. I try to put a 20 amp output breaker on the inverters. Now, the reason why I recommend a 20 amp output breaker is the breaker will trip before you can physically overload the machine. At 20 amps, you have roughly 4.7 to 4.8 kilowatts, depending on certain factors that you can pull out of the breaker before it physically trips. So that means that you can physically never get my inverter to go into EPS overload for tripping. You will always trip the breaker first before the inverter physically trips. The inverter has a protection that as soon as it reaches 5 to 5.5 kilowatts, it will go to EPS overload and it will switch off the machine to protect itself. It have all of that built in. But as soon as you claim a warranty and we see you are if you have a client that continuously overloads the inverter past 5 kilowatt and it goes to EPS overload, then you are abusing the inverter and then warranty won't be given. Which if you have a 20 amp output breaker, you can never reach that point. The circuit breaker will trip and then the client says, oh, it's load shedding, I have too much stuff on, and it can switch stuff on, off, and it can go to the breaker and only lift the breaker with the inverter never physically went into overload on the inverter. So that's why I recommend it. You can enter whatever size you would like there. I think the booklet recommends a 32 amp circuit breaker or 40 amp circuit breaker that you can enter there, but I recommend a 21 just to protect your warranty, if you understand what I'm trying to get to at that moment there. Okay. Okay. At this moment, let's say if you have a system that is pulling a lot of power, let's say you are charging your batteries, let's say at 2.5 to 3 kilowatts, and you are pulling 3 to 4 kilowatts in your house at that moment. Yes, then the breaker will trip at that instance, and you can install a slightly bigger one than 25 amp input breaker. But the reason why I don't like it is then you're pulling 6 to 7 kilowatts of power that's flowing through your machine at that moment. Um, so that's why I try to put my breakers personally so that the client can't have that big amount of power flowing through a inverter. It's a 5 kilowatt inverter, and I don't like it when there's more than 5 kilowatts flowing through the inverter. If that's 3 kilowatts that's been charging and 3 kilowatts that's been using in the house for whatever the reason might be, then it will still be a big amount of 6 to 7 kilowatts that's flowing through my inverter. So that's why I recommended 25 and input breaker. But as I said, it's your choice which size you would like to enter. We won't tell you your breakers was the problem on a warranty claim or so forth. We just go on the data that the inverter showed me. So I only put this recommendations there for one to try to protect everything on the machine. Clients don't always look at the amount of power that they are pulling. Clients get very comfortable with machines. There's no load shedding. They don't check the schedule anymore. And before they know it, they put on a few things and then they trip the inverters and stuff like that. Yes, I'm talking about a single inverter at this moment. I'm not talking about multiple inverters. So all this is per inverter. I'll get to the parallel setup slightly more down in the training manual, where I give all the breakers for parallel systems and so forth that I recommend on them. So this is just the recommendations that we have for you to try to protect the machine. Then, as well as an SPD, South Africa's grid is extremely unstable and we have a lot of spikes from Eskom side on the inverter. So an SPD to protect your system against a big spike. Then just lights to show if the grid is on and the inverter is giving out power. And then a changeover switch to bypass the inverter, especially for updates. So especially for updates, this one is very important, the changeover switch. And if something happens with a system, you have the capabilities to tell the client, just switch the changeover switch and power will be restored to the household or to the content that was running off the inverter. Now on the DC side, this is very, very important. A lot of my warranty claims come from the DC side of my inverters. We have a lot of installers that works with live DC wires. I can't stretch out this training more on this side, but very important of the DC side, don't work with live DC wires. We have a lot of installers that touches the body with a live DC wire and it arcs against my body and you damage my inverters. 9 out of 10 times, if you arc your PV panels against my body, you blow my main board. And you can't hide that arc marks from me. We can see it as soon as we open a machine, we can see on the body, there is arc marks on the body and your warranty will be voided. So please don't work with live wires on the machine. I know it sounds weird that I'm telling it, but we get a lot of warranty claims or inverters back of clients that you can see at arc marks on the body, if it's AC side or DC side. AC side, most of the times it's only an arc mark, but the inverter survived. But on my DC side, it's very, very sensitive. If you arc the DC side, your inverter, 9 out of the 10 times you will blow mainboard. So please tell the installers, everybody, not to work with these with live wires. If you have this installed, then there's no reason for you to work with live DC wires. Then you have everything to make it nice and quick to switch off your DC system. All your strings of your panels must have a fuse. Then on my MPPT range, we have an MPPT range of 100 to 480 volts on the MPPT side. So you can have your panels from 100 to 480 volts that it will work off. But my MPPTs only start to provide power once it's over 120 volts. So once it's higher than 120 volts, the MPPTs will start to produce power from your panels. My MPPTs also have a 13 amp maximum current that can run through my MPPTs. This machine has 2 MPPT trackers, so it doesn't have 1 but 2. That gives you a total of 3,200 watts per MPPT. So meaning that you can add 6,400 watts on the SNAs now. So you can overspec it by 1.4 kilowatts on your panel size, and the inverter will comfortably give you between 5 and 5.5 kilowatts from the panels if you demand that amount from the inverter. So the inverter is more than comfortable to give you your 5 kilowatts worth of power from the sun if you install the panels. Now, on the panel side, we have a lot of questions on your 540 watt panels. You see a lot of them are just below 13 amps or just higher than 13 amps, like 13.1 around there. So on 540s to 545s, they are still safe to use on the system. You won't get your 13 to 13.1 amps out of your panels. Even on a cold day for that short time, my MPPTs are designed to handle slightly higher amps, so you will be more than safe to use 540s. But as long as it's just higher than 13, it's fine, but not much higher than, let's say, 13.1 to 13.2 max that you can use before you will get into trouble then. So we have a 480 volt maximum. On the voltage side that you see here is my operating range. So that is the range within where a inverter is the most happiest on the MPPT side to work. So the MPPTs will be the most efficient if you keep it between, let's say, 120 to 385 volts. So that's where your MPPTs will give you the highest efficiency. You can go higher than that, but you lose slight efficiency on the MPPT side then, but the MPPTs will still work and they won't get damaged if you go higher than that. I try to tell the clients, don't try to go higher than 400 to 410 volts on the VOC side of the MPPTs. Try to keep it 400 to 120 to 400 is where I usually try to keep my panels in. Then from there on, I recommend, as I said, the fuses must be in, then SPDs. a 500 volt SPD on your system will be sufficient to protect the MPPT if there's a very big spike coming through. Then an isolator switch to completely isolate your system. Once you have installed your panels and you need to do something on the inverter, switch off your PV power at this isolator switch so that there's no capabilities for arcing your machine. The inverter will always keep its bus side active. So that means if you work with the machine that is switched on, your MPPTs and your battery side will always have voltage, so you can arc it against the body while the machine is on as well. So your panels must be switched off, your AC side must be switched off, and your inverter must be switched off. Once you switch off the inverter, give it at least 30 seconds for everything to for your voltages and everything to neutralize in the inverter itself, and then the inverter is safe to work on. Don't work on the inverter while it is switched on. I know I'm on this topic a lot with the working not on the inverter while it's on and that stuff, but we get a lot of returns on the units because of this. Now, this graph that I have added here, one of these days, this won't be necessary at all. The newer units that is coming in, all the new units that's coming in, you'll see I have a white sticker set on top of it. And this white sticker you will see says that the pin configuration has changed. Luxpower is using a straight communication cable with most of your brands now, like your Pylontech and your Shottos and your Dynasys. All of those batteries will be a normal straight pin configuration. The older Luxpower SNA 5000 used a pin configuration that pin 3 of the inverter went to pin 5 of the battery and 4 stayed on 4. Now, with the newer machines that's coming in, we won't have to worry about this one anymore. We will only have a straight communication cable that will work between the inverter and the battery, and 99% of the batteries comes with a straight comms cable in the box. So this is a big improvement that we are very excited about. So we won't have a cross configuration anymore on the battery side on the cable pinout anymore. I think a lot of the installers will also be happy about the change that we have made here. This is the server address. If you have a look here, if you want to copy that, you can just copy it in, and that's the exact address for Luxpower login. Or you can go to Google and just type in Luxpower login. That also works 100% fine. So this is just the settings that you'd have available. Now on this is where we get to our parallel system. To parallel these units, all that you're going to need is 2 or more, depending on the amount of units. Let's say there's only 2 units, then you'll need 2 straight RJ485 cables. So it's normal internet cables, as a lot of clients call it a LAN cable. So you only need a straight pin out configuration. The machine comes parallel ready. The machine comes with a dongle in the box. So you don't have to buy a dongle separately. That comes in the box. All that you're going to have to buy separately is your communication cables, your LAN cables. They are fairly inexpensive, so it's not difficult to get a hold of normal straight comms cables that you have. So for this one is the main thing that you must remember out of your parallel system is your configuration of your cables between the machines. It's very important that you know of the parallel ports. It's marked parallel ports. The first parallel port is connected to the last parallel port of the inverter. If there's 2 inverters, it will go from the first one all the way to the last one. Then the parallel ports that's in the middle will be connected like this. That's if there was 2 inverters. If there's 3 inverters, the configuration stays the same. The first one going to the last inverter, and then it just daisy chain to the inverters. Then from there, if there's 4, everything stays the same. Now at the bottom, you will see there's a dip switch box. My new machines will be blue. You will see that the dip switch box is blue. On that dip switch box, the first inverter both dip switches must be on, and the last inverter, both dip switches must be on, and the ones in the middle must be off. Now, if there's only 2 units, it stays exactly the same. The first unit on and the second one, both of them on. The unit that is using the communication cable that's plugged into the first and the last port, this is the ones that 2 dip switches in the box must be on. This is how the inverter knows which one is the first and which one is the last inverter in the communication chain. If there was 3 inverters, this box on, off, on. So this is how the configuration are between the communication between the 2 machines. We can do up to 10 units in parallel. I know they said they are testing up to 12, so I'm just fairly waiting for the reports to confirm that 12 will work 100% in parallel. But as far as I know for a fact, 10 of them works in parallel mode. Is there any questions before I go to the wiring side of the parallel system, just to explain my breakers there on the communication between the 2 inverters? Is there anybody that would like me to explain something there again that I maybe went too fast through or something? Okay, I see there's a question. Okay, do this. Okay, what this 2 dip switches basically is doing is it is a resistance that is added to that specific line, and that's how the inverters knows which inverter is where. So if you add your 2 dip switches up, then the inverter knows this specific unit and this specific unit is the first and the last unit in the communication chain. That's all function that this 2 dip switches boxes have. If there's one inverter, then it doesn't matter where this dip switches are, your inverter will function normally. So if it's one inverter, it can be up or down. I usually tell the clients leave it at the down position. That's how it comes out of the factory, at the down position, but it doesn't matter if there's one inverter. But as soon as there's more than one for communication wise in a parallel system, this only assigns the first and the last inverter for the system to know which inverter has this specific communication chain on it. So that's basically all that this dip switch is designed for, just to tell the inverters you are first and you are last, and all the ones between you are in your communication chain. Yes, it's exactly the same for single phase and 3-phase systems. And yes, I always use 2 communication cables in parallel. It will work with one alone. If there's only 2 inverters, it can function with one, but I always put in 2 cables, even if it's only a 2 units that's in parallel. So I always use both ports on my inverters. If there's 2 inverters, still 2 cables. As soon as there's a third inverter, you will automatically use all your ports that's available on your machines. So yes, the configuration stays exactly the same for the 3-phase system. All that you're going to have to do is you're going to have to tell this inverter, let's say this was a 3-phase setup. So let's say this is your first phase, your second phase, and your third phase. Then you tell this inverter your R phase, your S phase, and your T phase. And then you can tell the fourth one you are one of the other phases as well. So this could be your T phase, for example, there's 2 inverters, and this could be R and S phase. So that's depending on how you like your setup, but you can have that there's 4 inverters in a 3-phase system, 5, 6, depending on how you'd like to configure it. But yes, you can have a 3-phase system with 2 inverters on one phase and one on the other phases. You just have to tell the inverter which inverters is working with which phase. Any other questions that one has here before I go on? Okay, I'm going to go slightly more down on this parallel system here. So for this instance here, you can do the parallel settings on the screen of the inverter or online. I usually quickly go on the screen of the inverter at setting 21. You will be able to do your parallel settings. Let's just quickly go slightly higher. Okay. So once you see this page online that you have here, you can select system type, that's single phase or three phase. Parallel, then set composed phase is for a three phase system. And then something that I have a lot of questions about is your battery shared. Now, once you have a parallel system, I always recommend that you use battery shared, meaning I have two inverters or three inverters, and they work off the same battery bank. So I have three batteries for each inverters. Parallel that three batteries to create one big battery bank and run the inverters, all three of them, of the same battery bank. Then you tell the machines we are working on the same battery bank, and the master inverter, that's the one that you switch on first, or the one that has the communication cable from the battery, will relay all the necessary information to the rest of the system, and they will listen to him about the charge voltage and all of that. So if the master inverter starts to charge, all of them will charge, and it will go on like that. So battery share just gives you the capabilities to keep all your inverters of the same battery bank, especially in a three-phase system. In a three-phase system, your phases isn't balanced 100%. So if you have a 5 kilowatt battery on all three phases, one of your phases will drain its battery faster than the rest of the phases, and your inverter will switch off at a certain point if your battery is flat. And as soon as you lose a phase in a three-phase system, the system will completely shut down, and your whole system will be dead until your battery power is sufficient for the system to start up again. Now you still have 3 kilowatt in the one battery left, and the other one has a kilowatt left. So you have technically 3 kilowatts worth of power that you can still use. But one of my phases batteries is dead. But if it was a shared battery bank, you can use the maximum amount of capacity of your batteries, because then all three inverters will use that battery power, and all three inverters will charge this battery and all of that, if you can understand what I'm trying to say there. So battery shared is one of the functions that I always try to enable on my machines, always of one battery bank if it is possible. If it is not possible and you have different type of battery brands and sizes on different machines, then you can just give all the machines its own battery and the information of it on its own. Then from there on, as I said, 10 units in parallel, the battery shared, I touched there. Then on the AC side that I had on that list, we recommend that every single inverter in a parallel system have its own input breaker and own output breaker. Because if you have a parallel system and one of your inverters is not functioning correctly, you can isolate that inverter from the whole system, and you can still use the other inverters in parallel mode to give power to your EPS side and your loads. So the breaker sizes stays exactly the same on a parallel system if it comes per inverter. So meaning you still have your 20 out and your 25 in per inverter, and from there on you can do your parallel work to the size breaker that you need for the amount of inverters that you have installed. But per inverter, the breaker size don't change, even if there's 10 of them in a row. Each inverter will still have its 20 and 25 amp output breakers, and from that breakers it goes to a, let's say, a live bus bar and a neutral bus bar where the parallel work happens, and from that bus bar it can go down to a circuit breaker that's the correct size for the amount of power that all the inverters together can provide. And then all the inverters needs to have AC input to work. If it's a parallel system, you can't give AC to only one, it will not be happy. Then generator port as well. If it's a parallel system, both inverters or all the inverters in the system needs to have power on the generator port, and install a circuit breaker for the generator port as well, please. Then on generators, it's a very difficult thing on the inverters, the generators. If you have a generator that's fluctuating a lot on the volts and the hertz side, the inverter won't use your generator. it will try to use it, and as soon as it tries to use the generator and your power and your voltage dips on the generator, the inverter will leave the generator, and then the generator will stabilize again, and then it will see if it can use it again. That's why I recommend 1.5 times bigger generator than the capacity of your system. And if you have, let's say, like a 7.5 kilowatt generator, I always tell the clients, try not to use more than 50 to 60% of your generator's capacity to keep your generator at a stable level where your volts and your hertz are stable. The inverters does not like a generator that's fluctuating on the volts, and especially on your frequency. Your frequency needs to be as stable as possible. The inverters doesn't like a fluctuating frequency at all. So that's on the parallel system. Anything that you'd like to ask on the parallel systems before I go through some of the description codes that I could touch on? Okay. So I've also added in the training manual the description codes of the inverters that you can see which code means what. The happy codes, a lot of clients ask it. You'll see CO a lot of the times, 10 you will see a lot of times, and 14 as well is some of the codes that you'll see a lot of on your inverters. All of this is in the training manual. You can read through it, and on the side is the description of what is what code that happens at this moment. Then on the error codes, here's some of the error codes that you will see on the inverters. You can go through them, and it says what is happening on the system. 08 is one of the biggest ones in a communication chain on a parallel system that you'll get. That means the inverters is not communicating exactly as it should. So that's 08 that you'll get a lot of times on it. Then 12 you'll get a lot of times on a parallel system. If your system is not wired correctly, you will get setting 12, or you will get fault 12 as well as fault 13. You will have a lot of times in a parallel system if your wiring work is not done correct. In a three-phase system, you will get error 15. If you get an error 15 in a three-phase system, all that you're going to have to do is or tell the inverters to switch phases. So you go to the parallel settings and you say this one that was R phase are now S phase, and that one is T phase. Just swap your phases around on your machines, and then your machines will be happy, or you can physically change the phases as you like. But that just tells you, you said this is phase 1, but it's detecting that it's actually another phase from Eskom. That's why it's giving you this error. You'll get that in parallel systems quite a lot. Then let's go on from here. Okay, now bus voltage high. We get a lot of this bus voltage high warnings with certain batteries. It's not necessary that it's your panels that is your problem at that moment. If your panels are, for instance, charging your battery, and your battery stops that charge for that instant at the voltage that's higher than the battery recommends it, then the bus voltage of the system goes higher than it should be, and then it gives you a bus voltage high. There's certain batteries that we're having a problem here and there on certain inverters with it, where the Lux team usually just do an update and do a setting or two, and 99% of the times it's fixed. We have systems here and there that's slightly more sensitive to that, that they are working on updates to improve this bus voltage high. But the bus voltage high is something that happens as soon as your panels usually charges your batteries and the battery's BMS stops. And it's usually where a battery has an imbalanced cell, that the voltage goes higher on one cell and then it stops at the earliest stage in the charging cycle. Let's say the battery should reach, let's say, 56 volts, but it stops at 53 or stops at 55.3 or 55 volts, and then the BMS will completely cut off the charge, and then the voltage between the inverter and the battery will go higher than the BMS cable tells the inverter it is, and then it gives you this error that happens on number 19. So we have a few systems. After a lot of the updates that engineers has done on the logic of the inverters, it improves that voltage one, but it's not an error that happens on a lot. We just have a few systems that happens after the updates. 99% of them are completely sorted out. Then From here on, you have your warning codes. 00 is one that you will have a lot with. So that's communication failure with battery. So just check your battery protocol, and if the battery is compatible, it's very important to see if your battery is compatible with the inverter. Then 08, a lot of the guys and update your inverters. Something that I didn't mention at the top, updates. If it's a parallel system, always update your inverters to the newest software available. If it's a parallel system, to ensure that they are on the same firmware, and that's the only way that you can do it, is by updating it completely. From here on, there's not much of the warnings that you'll really get to do with, so you can have a look. Then the other one that you'll get a lot is your 26. That just tells you your battery voltage is low, so your inverter will still function, but it just tells you your battery is low. If your battery was drained, let's say to 20 or 15%, 26 will come up and just tell you battery voltage was low. And then roughly between 5 to 10% after the warning has started, if you charge your battery, it disappear. And battery 27 is battery open. So when you have a system that is communicating with a battery, you'll see a lot of time error 27, and the inverter shows there is voltage. As soon as you have a battery that communicates, your battery sends its voltage via the communication chain or communication cable to the inverter. So that gives the inverter an estimate or the exact value that the voltage of the batteries is. So if it's a battery that communicates and you get 27, then you can just check your fuses and everything to make sure that your battery is physically giving out power. The easiest way to do this is physically switching off your inverter, because the inverter will always try to keep the buzz line active, and it will try to wake up the battery by pushing 40 to 45 volts through the buzz line to see if it can wake the battery. So if you get this error and you're not sure if your battery is giving you power, switch off the machine completely, switch on your battery, and measure on your terminals of your inverter itself if you find any voltage on the terminals of the inverter itself while the inverter is switched off. So that's one tip that you can go from there on. And then more to the bottom of the training manual. Oh, before I forget this one, if you have a warning face and a sad face at the same time, the two faces on the screen, then it means there is a fault. It's not a warning, it's directly a fault code that you are looking at. For instance, on this inverter, you will see in this box here, there will be a sad face and a unhappy face at the same time. Then it means it's a fault code and not a warning code anymore. You get that quite a lot as well, so just take note of that one there. Then slightly more down is the battery compatibility list. We have sent the new updated version as well in the chat there for you on the new batteries, and then you can read through some of the settings here on the screen. This is some of the quick setup guides, how to do certain working modes of your inverter while you're on the screen of the inverter. So I've said that in there as well. So that's basically that on the training manual that I can speak to you guys about. Is there any questions that one would like to have about any of this training manual that I have here? Any questions about the setup, certain parts that I maybe went through too fast or didn't explain in depth that you'd like me to explain in depth? The last thing is the account that I want to show you how to create an account for your installers or the distributors for the installers, so that you can also see how the accounts are created. Now, all the questions, I see there's no questions for now. So let's quickly go to the accounts along while we're waiting there. So I'm just going to log out here. So I'm quickly going to one of the distributors accounts quickly, so that we can have a look how to create a installers account. So once you have a distributors account, like all the AC/DC groups and everybody has the distributors accounts for their clients, you go to configuration, you click on the configuration tab, you go down to the users tab, you click on the users tab, and then you see the capabilities to add certain users at this moment. We will send the compatibility list again on the chat as soon as I'm done. I believe it was sent before you have added. We will send it now again. At the end, I'll share it again with everybody. Okay, so I'll send that now. Before you leave, please don't leave. I'm almost done with this, and then I can share all of that information again with you before you leave. So the last thing is to add a user. So you're going to say add installer. So this is where the installer account comes in. You only have to do it once, and from there on, he uses the same account with all his installation. So you can enter his username there, his password, email address, Africa. Then it's going to go South Africa, and then at the bottom, South Africa again. Time zone, GM+2. English, his cell phone number. I only enter a point at the address, and then the customer's code. You'll see the customer's code. I exactly use the same. Let's say it is Yanni is the account that it needs to be. Then I take the username, I copy the username, and I paste the username. So I have the username and the customer's code. I use exactly the same username and customer's code. Just to keep it easy for the installer to remember his customer's code, because he's going to use it from here on. I see I have a few questions here. Oh, I see they have sent the list again. Okay, priority settings. I'll quickly go through that for you as well there. Yes, we will definitely do the video as well. Okay. For priority settings wise, I just want to quickly see on, and then you at the bottom, you just add the account and then you can send it to the client. I usually take a photo of the account and I send that page that I was on. I send that photo to the installer after I've added it, and he has his account and he can log in from there on. I just want to see, okay, this is an SNA. So let's just quickly go in here. Okay. So most of your settings will exactly be the same. Now, priority wise, okay, let's say you have a system that you would like to, let's say AC first is a backup system. It's only a backup system. Then at your AC first, this tells the machine it must only use Eskom and not something else while Eskom is available. So then you basically just enter 2359 at that moment. And then you press the set button and it will set it at 2359. So the other values I don't use. I only use the AC first start time 1. The other ones is not necessary, and the start will be 0000. So that basically tells the machine that it will be active 24/7 on AC first. Then the last thing that you have to activate on the UPS system is your AC charge. You press it according to time, and it will be the same 0000 and 2359. And you press set after you are done with all your settings. It will tell you successful, and then it is set up to AC charge permanently, and it's as a backup system. Now let's say, for instance, I have a system where I want to use solar, then utility, and then battery. Then all of this will be the same, except all change that you're going to have to do is the PV and AC jointly function. You enable this function, and then the machine will use all available PV power with Eskom power as far as possible, and then just go over to your Eskom as soon as your PV is no longer sufficient or no longer there to provide load. With this function, if there is a 2 kilowatt load and your panels provide only 1 kilowatt, it will use 1 kilowatt of your panels and 1 kilowatt from the grid combined to provide the 2 kilowatt load. So this was for a system that's running on solar utility battery. So just to recap that one, solar utility battery is AC first you put on, you enable the PV and AC jointly function, and AC charge you can also enable. But if you don't want your batteries to be charged by Eskom when there was load shedding, and you only want your batteries to be charged by solar, you can just disable AC charge, and tomorrow morning the solar will charge your batteries and then provide to the loads again. Then from there on, that was for solar utility battery. Now, if you have a system that you want to use solar, battery, and utility last, then you switch all of this off, 0000. At AC first, you tell it may not use Eskom at any certain time. Then AC charge disabled. Then from the last step that you can do there is your on-grid EOD or your discharge cutoff. You can set to whatever desired level. So discharge cutoff SOC will be at 20% or 15%, depending on the battery that you have, and the on-grid EOD. Now, your on-grid EOD is the value at which your inverter will kick back from Eskom. I will kick back to Eskom while Eskom is available. So if I set it to 50%, my batteries will be drained till 50%, and then it goes back to Eskom while the grid is available. And once the grid fails, it will go to discharge cutoff SOC. That's the lowest that the batteries will be drained while the grid is not available. So this gives you the capabilities of using a small amount of your batteries every night and still leaving a small amount left for when there's unforeseen power outages in certain areas. So that's how you're going to do a solar battery utility. Then just remember, if you pick PV AC jointly, then the machine will use PV and AC as far as possible to provide power to the load, even if your batteries are full. If you don't want to use Eskom at all, you disable this function. Then it will use the panels, and if the panels has a shortfall, it will take it from the batteries until your level where it is set to at the bottom. Let me quickly see. I have a few questions here. Okay, let's quickly see. If you mean if it can use all sources at the same time, the inverter can only use your PV and your AC jointly, or it can use PV and battery at the same time, or only AC. It can't use PV, battery, and AC all together at the same time at that moment. Your PV power will always be prioritized to your batteries first if your PV AC jointly is not active. So as soon as PV AC jointly is active, then the inverter will prioritize the panels to the loads first. If your PV jointly function is not enabled, then it will firstly give the panel power to the batteries to charge the batteries, especially if you have this value set here, your on-grid EOD. So let's say your batteries was drained till 50%. The panel power will be prioritized to charge your batteries first up till 60%, and then it will start to use battery power again for certain functions. So if you want your panel power to firstly charge your batteries, then you're going to have to have this one disabled here, and then it will automatically charge your batteries and then provide to the loads. That's after that one there. From there on, let me quickly see. I missed another one. Can the Luxpower export to the? Okay, this Luxpower, the SNA 5000, it can export to the grid, but it doesn't have a CT. So that means you can't limit it to only the power that's on the non-essentials. If you want to limit your power to the non-essential loads as well, but not push back to the grid, then you're going to have to buy a full hybrid inverter. This inverter, as I said, a hybrid function that it has, so PV and AC can be used jointly. as well as export to the grid. So if you have an old meter installed, then you can export to the grid as well. And it will export to the grid if you allow the machine to do it. It's at your capability to switch it on and off for the export wise. If you want a machine that can do the CT, you can go at the LXP range that we have. So the LXP range at this moment, we have the 5 kilowatt, the 10 kilowatt, and the 12 kilowatt that's coming into South Africa now. We have already a few 10 kilowatts that's running this side. That's running quite well, and the 12 kilowatts should be within the next week or two. We should have a few 12 kilowatts that's coming into South Africa that we can install and test how the system is running this side. So if you'd like to have a 12 kilowatt single phase unit or a 10 kilowatt single phase unit, then Luxpower brings them out as well. I'll put the data sheets as well in the chat so that you can have a look at the data sheet. Something interesting about the data sheets on the Luxpower inverters, you'll see that my 10 kilowatt unit can handle up to 14 kilowatts for 10 minutes, 16 kilowatts for 5 minutes, and 20 kilowatts for a half a second before it goes into overload mode. I'm just quickly gonna get everything shared here. If you give me a second, just quickly getting all the files ready so I can share all of them at once to everybody that can download them for me. Let's go down here. Okay, I'll quickly share all these files with everybody here, and then we can go on from there. That one we're going to use. Then this one here, and okay, there's the first file. Second file has been sent there. That's the 10 kilowatts thing I'm sending there, and then that one there. Okay, I see the files are sending at this moment. Luxpower training file is sending. The first one is sending, and then the last one that I'm quickly going to send to you guys is the video that I'm sharing about how to get your dongle online. So that one is also on its way at this moment. Okay, so the video is also sending. So let's just give a few seconds. You should start to see some of the files coming through now. I see my training manual is almost done sending. The first two data sheets of the two inverters is also going through, and then the last one is the video that is sending now. I'm quickly going to see if I can share the data sheets along while we're waiting for your training videos to be sent through. Is there any questions that one have while we're just quickly waiting for the files to go through? Let me open this one. I'll share this file now, then we can go through some of the specs that this unit have while we're waiting for some of the files. New share. Let's quickly go. Yeah. Okay. I believe everybody should be able to see the screen now of the new. So this is on this side is the 10 kilowatt inverters specs that we have at this moment here. Okay, let's just quickly. Okay. Please explain the graph on the home page. Okay, I'll quickly go back there for you. I'll send that spec sheet to you as well. Okay, let's just quickly go back before. Okay, let's just quickly go back. So I see that question. Okay. I presume that you are speaking about, let's see if this one's going to have a graph here. Let me just quickly go to a system that I know that should have one. Let's go to this one. Let's go to this one here. Okay. If you can just quickly answer me, is it this graph here that you'd like me to explain, or is it this one at the bottom here that you'd like me to explain? The first or the second graph? Which one would you like me to explain? The second one. Okay. 100%. Let me quickly explain the second graph to you here. Okay, what this graph means is according to the time, every 5 minutes my inverter updates its status to the service. So all points you'll see is a 5-minute jump that it makes. If you can have a look there, 30102, then it jumps and it goes on like that. Okay. So let's say, for instance, at this moment here. So at this moment, the sun is quite shining nice at this client's house. You have maximum amount of panels on the inverter. So at 11 o'clock, we can see that the solar was producing 5.2 kilowatts worth of power. The batteries was charging at 42 watts. That's the bus voltage that's active constantly. He was exporting to the grid. He has a house with a workshop. So all the power that's exported from his house's system goes into the workshop and is being used by the workshop. It never reaches the grid, this client. And then the consumption that was on the inverter was 902 watts. So this graph gives you just an estimated of what was happening on the inverter at a certain time range. You have your date here that gives you what day it was, and then the color configuration at the top, the solar battery grid. So if you keep it on the solar, it highlights the solar graph, so you can see what your solar done at which time, what was the power that was there. On the batteries, you can see the discharge on the batteries and the charge, etc., on the batteries at that moment. So for this instance, the batteries was charged a little bit and then was stopped. Then the grid, that was what the grid was doing at that certain time. So you can see the grid done this and the grid done that at this time, and then the consumption, you can see the loads, what the client have done. Then if you go slightly lower, as I said, this is just a generalized information that was put together of the day. So at certain times, you can see for this client, let's have a look at this day. At the 5th of this month, you can see at 39.3 kilowatts that he generated from the system. The second day he got 39.1, the day after 38.9, and here he got slightly weaker generation, and here he's up to 38.9 again. So then you can also see the battery. The battery was used, the export to grid, and the consumption on the specific days at that moment. Okay. Yes, the grid will always be opposite what's on the graph, as you can see here. He only uses his batteries in the backup. He doesn't want to use his batteries at night. He wants them for backup only this line. So you can see the grid mimics that one here. If your red line is there, and like here, there was no grid. So you can see your battery and your PV was working together there to provide to the loads at that specific instance there. So the grid will always be mimicked, and then as you see here, he's pushing back to the grid, so that's why the grid is above the line and not at the bottom of that specific line again. Now my SOC, I can't have my SOC at this bottom graph here, but what we can do is if you go to data, then you can have the SOC of the battery displayed at this instance here. You have a battery that can't communicate, so he's running on voltage levels, so he we'll have a look at the voltage chart of his batteries at that certain instance. So this is where you can have the slightly more in-depth information. At which time, where were my SOCs of the battery? So here's the graph for your SOCs. Here at the bottom is the graph for the EPS power that was sent out. So this graph is for when there was like load shedding and the EPS power was sent out of the inverter. Here is basically the data of the grid. the voltage of the grid and all of that of the grid that happened. So here you can see was his load shedding this morning. So he had load shedding from 8 o'clock till just past 10 this morning. He had load shedding. At this moment, you can see his voltage of each MPPT. As I said, there's two trackers. So you can go to the second MPPT. You can see its lines as well as the wattage that each MPPT was producing at that moment. So you have fairly data that you can play around, and at the batteries you have the charge that you can have a look at what happened to the charge voltage, and as well as the discharge power that was running off his batteries at whatever time at that moment. And then if you want to go more in depth on what the inverter sends back to the servers, yes, I am not going to go through all of these. There's a lot of explaining work to happen here, but you can see all of the information on the graphs will then be plotted out here. So you can go through these ones as well if you'd like. All the information about certain points and data points that the inverter sends back. If you understand this type of data, you can go through them as well on the inverter. Okay, is there any other questions that one have about the monitoring page before I go back to the spec sheet? So at this moment, I'm basically done with the training. All that I'm going to go through is the spec sheet that I have shared. So I'm basically done with the training on this SNA. I see there's not really much questions that's coming in at this moment. So there's one question. What do you mean the generator to be controlled by the inverter? To stop start the generator, or to okay, so to stop start the generator. Okay, I'll quickly have that for you there. Under configuration, devices, description of status code. Okay, let me quickly have a look there. I'm just quickly trying to see where you mean in your question. If you say under configuration, then you go to devices, description of status code. Okay. Status code. So I presume that you, let's quickly have a look here just to make sure that I understand exactly where you're meaning of the description. Just give me a second here. I just quickly want to pull up everything on my side just to check where he's exactly asking the question. Yeah. The serial number, yeah. I got your configuration, devices. Okay. Next to firmware tab. Okay, that status code. That status code is equal to, let me just quickly have a, is equal to on the training document. I'll quickly share the training document so I can just quickly show you there that status tab there. Okay. Just quickly trying to get that up so I can show you there. Where is that one there? Give me 1 second. I'll just close this one. Okay. The status code that's showing there, I'm just starting to get that paper for you. Okay, the status code that is shown there is the status of the inverter at that moment, in which working mode it is working at that specific moment. That's the status code. That's that. Where on the training manual you'll see the status codes that's in the training manual. It gives you certain status codes. That's what that status code is. That's in which working mode or which status the inverter is at that specific moment. If that answers your question at that moment there. Also using a lithium battery that is not compatible with the Luxpower, do we? Yes, you fairly get almost all of your capabilities out of your lithium battery if it doesn't communicate. You put it on voltages. All that your communication cable basically does is tells the machine at which certain levels your battery needs to be for your charge voltage, your float voltage, your cutoff voltage, all of that. That's all that the communication cable is doing the whole time. And it just gives you a much more accurate SOC level of the battery. So once your battery can't communicate, you work off voltages, and that tells the inverter at which levels it is. Tells inverter, I'm at 30%, now I'm at 25%. As soon as you're working off voltages, you don't exactly know the level of your battery, but you know at 48 volts, your battery should cut off. That's basically the same. I see you're only on the PDF still. Okay, and that's fine. I'll go to the PDF now of the things there. So that's basically what yeah. So that's basically on a system that has batteries that can't communicate. You're almost getting the maximum capacity out of the inverter. It's not a big loss that you really get on the inverter, on the battery, if you put it in lead acid mode. No, the SNA you can't put for that on the Cape Town list. You're going to have to buy the full hybrid version to do that. The SNA is technically labeled as an off-grid inverter that has hybrid inverter functions to make it fancy and to get it above the competition. But no, if you want to go on the list of Cape Town and do all of that stuff, you're going to have to buy a fully hybrid unit. And all my LXPs are registered, NRS approved, and on the list of the Cape Town. On-grid inverter to this Lux. How do you mean with on-grid inverter? Do you mean like a grid type of inverter to this one? How do you mean can I connect on-grid inverter to this Lux inverter? Can you just collaborate that question slightly better? I don't understand exactly what you're asking at that question there. As I understand, you're on the PDF here for the 10 kilowatt. I have shared all the information on it. Just some nice facts to know that it can handle up to 16 kilowatt on the DC. For the panels, can go up to 600 volt VOC. Then the operating range that the inverter is happy with to work off is here from 210 to 500 volts on this unit, and it has 17 amp MPPTs on this unit. Then it has 3 MPPT trackers and not 2, so it has 3 MPPT trackers on the new 10 kilowatt unit. Okay, so what he's meaning is like a contactor type of thing to bond your neutral and your earth, if I understand correctly. Oh, the generator signal, yes. Okay. I'm sorry, before I get away, I was busy with the generator signal, then I got busy with other question. Okay, the generator signal at the bottom of this inverter is a normally closed and a normally open circuit that runs off it. I will get the diagram and send it to you. I have a full diagram that I have received of Lux. Can I just ask, I'm just going to send you a personal message quickly here. If you can just send me a WhatsApp, I'll send that diagram to you on WhatsApp. We're just quickly going to have to search for it on the computer, and then I can send you the full diagram and setup wise of the generator there. So I'll send that quickly to you there. So just quickly send me a WhatsApp there, and I'll quickly get all of that for you there. And that's basically it on this training session that we have here for today. Any other questions that one might have that we can quickly run through before we end this session? I have sent all the manuals and the specifications of the new units. Please have a look at it. The new units will arrive within this month, and it's absolutely the next generation unit. The screen is a big, nice touchscreen on it, and it feels like a phone that was sticked on the front cover of the new units. And the online monitoring system, as it's online, is on the new units. So that's basically it. I hope everybody has all the files and enjoy your day. Thank you for coming to the session.